next on the stage is Marianna Diachuk. She's a data scientist at Restream and data science lead and mentor in the local branch of Women Who Code community. Former data scientist in Data Robot and former lead of data science team at a fintech startup. So she loves to share not just her technical experience, she's passionate about science, traveling and writing, and today she's going to talk about some failures, deploying machine learning models and all the things that can go wrong. That's what we are going to hear about. So a round of applause for Marianna. Let's hear from her.
Hi everyone. Today, as it was already mentioned, we are going to talk about deployment of machine learning models, and mostly it's going to be in the format of some of the failure stories that I had in the past. And I am, as it was already said, a data scientist in Restream. And Restream is a startup which works on a multi-streaming platform, and we have offices in Kyiv and Tallinn and in Austin. Also, I am leading data science sphere and direction, like in the community Women Who Code in the local branch of it, as well in Kyiv. And also, I've been deploying machine learning models for like 5 years, and I'll be sharing some of the experience I had over this time. And just a disclaimer that it's going to be mostly about the experience I had in the beginning of my career. And so I'm not going to be mentioning specifically what I'm doing right now in Restream, but if you have any questions about that, you can answer that. You can ask them later on after this presentation as well. So basically, in deployment, really a lot of stuff happens in the wrong way and not in the way as we expect it to happen. And today we're going to dive more into what's the difference between model training and deployment. I also gonna tell you 5 failure stories that I had like in the beginning of my career. And since right now I have more perspective into that and understand more what I could do differently to prevent that, I will tell you about that as well. And then I'll share my insights, and you can take them with you as well and learn from them. So let's refresh our knowledge, or maybe it might be new for you as well. What's the process of training a machine learning models? So basically, we just start from gathering all kinds of data that we need, and it might be completely different sources of data from different databases, different groups of data. And then we do EDA, or exploratory data analysis, where we just dive into the data we have and we try to understand what are the patterns in there, what we can use for the model in the future. During feature engineering, which is like next stage after that, we try to extract the most important information from our features so we could train our model on these features. And then model training happens. And basically, all of these 3 stages, which are going after feature engineering, model training, model tuning, and model evaluation, all of these stages are happening they are all interconnected. And we train a model, we tune it, we see maybe we need to take another algorithm and retrain our model, or do something differently, like go back to feature engineering and change our features, or create some other ones and go back to gathering another group of data or using another data source. And model evaluation here as a final stage is more about not just evaluating the model while training, but more about looking at the last moment at the holdout and seeing what are the metrics, and that's already the moment when we still can go back to change something, but still we don't want to tune into and optimize to the holdout data that we use for evaluation. So basically, training model is completely different from deploying a model. We even use different tools for that. As you might see, for training a model, for you it's on the left, you probably know all of these libraries and instruments and use them for some of the projects, or at least heard about them. And on the right, you see that this mostly tools which we use for deployment. For example, it can be just frameworks like Django and Flask in Python, if you're coding in Python, of course. Also, it can be, for example, MLflow, which is also helpful while training, but it's mostly focused on deploying models, and you can do some kind of a custom solution using Docker and, again, some frameworks. It can be either Python frameworks or any other frameworks you might want to use. So basically, it's not just the only thing that differentiates deploying a model from training a model. And so let's talk a bit more about what does it mean to deploy a model. So we have like several, I would call them configurations of deployment. And here I'm mostly talking about a custom way of deploying a model, because if you are using, for example, AWS or using MLflow or Kubeflow, there can be some stuff can be similar, but some can be different. So it really depends on the tools. But here it's more about custom solutions. So it can be just microservice architecture, and our prediction service is just like a part of the system. It's embedded into the system itself. For example, when do we need this kind of deployment configuration? For example, like in the past, I worked a lot on fraud detection, credit scoring systems, and let's imagine that we have a fraud detection model, and there is kind of like a funnel of user applications, and we have some different stages which reduce the number of applications till the very end, because not like every client does all of these actions. Like some clients don't want to add documents, or like they cannot do that for some reason. Also, we can have some other different steps in the process of decision. And also we have the model, which is like basically embedded into the system. It makes decisions. That's why it needs to communicate with all the other parts of the system. For example, if it's fraud detection, again, it can be about communicating with the backend to make some kind of decisions. And this response, like the response of this model, participates in all of this decision process by cutting off some of the user applications as well, and then some other steps might be happening. So basically, in this case, our model is a part of the system. Another way to deploy a model is to deploy it as a separate entity. And for example, we might have just some kind of ETL pipeline that we created. It can be hosted anywhere, like on any place away from the backend, away from any other component of the system. And we just get a request to provide some predictions from our model, and it can happen, for example, in a scheduled manner. You can use like some cron jobs, Airflow, or other tools, or it can be just made per request. And we might need such kind of a deployment. For example, if I was working on churn prediction model for a marketing department, and they don't need to get these kind of predictions in real time. They don't need to update them that often because they don't have as many clients, like not as many clients are registering every minute or every second. They, for example, need new predictions every week or just every month, and they check it for example, some monthly reports or something like that. And that's why we have a like scheduled deployment, so they just get when they need these responses, and in such a way the model is not embedded into the system because it's like separate and just needed for functionality of one department, and it's not related to the product itself. The product can be anything, and it can do anything else not related to that. Or we can have like just per request deployment. For example, again, we have some kind of reporting and we want to predict sales, for example. And what we try to do is we are getting predictions when we just need that, when we are working on that, and we try to get these predictions just at that moment, but we don't need them to be updated by themselves. So I'll be like mostly referring to the first configuration of deployment, because This was like the first way which I used in the beginning of my career, and it's like one of the most probably common ways to do that. And basically it works in such a way that you create a prediction service which communicates with the database. You have your model pickled, but not necessarily pickled. You can use something else for that, but it's this model is has a constant state. It's not changeable because you already trained it and you're not changing it in production when it's already deployed. So you get some kind of a request from another part of the system, from end user application, and you give away predictions. So as you might see, the process of deploying a model is completely different from training a model. We might have even like different stages. For example, the first would be not to gather data or train a model. That would be to create ETL pipelines. And I would say that although a lot of data scientists kind of distinguish these two actions, to train and deploy a model, I usually try to create ETL pipelines while creating features, while features engineering, because you already can reuse these pipelines. And even if you're trying to generate thousands of features which you're not going to use in the future for your model, even in this case, you're probably going to reuse these features for something else. For example, I had a lot of cases like that when I just created a pipeline for some group of features which I didn't use for the model eventually, but then I was doing some kind of research for something else or creating another model, and I was just reusing this pipeline, which was very convenient. Also, another step would be trying to reproduce your results. And by that, it means that you created your ETL pipeline, and if you work like in this scientific experiment-like manner, like many data scientists do, you basically have like some kind of scripts and experiments, all of this running. And when you get to your final model, you already have really like a lot of different stuff that you're not going to use for your model. So you need to check for sure when you try to create ETL pipelines in deployment and to get predictions from your model that you're actually getting the same predictions which you're evaluated, that you're getting the same values of features. So basically it's about checking whether creating this separate deployment is the same as what you've been doing when you've been experimenting. And again, like creating ETL pipelines earlier makes it much easier because you already use these pipelines, and probably you like the probability of having the same results is really high in this case. And also you are testing integration, which is more of a software development classic step, which means like you're testing how your service works with the system, what kind of responses it gives, like what are error messages, how it communicates with other components, and etc., etc. So it's mostly about not the model itself, but just your service. So as you see, there are several issues you have to focus on during deployment, which are not that important during model training. And it might be obvious if you have a lot of experience in software development, but in data science, it's slightly different because you have like another mindset when you try to train a model. You are mostly thinking about model accuracy. You are thinking about having some hypotheses and running them and checking if they are correct. And that's not the moment when you're focusing on infrastructure, for example, because you probably already thought of where you're training your models and what you're using for that, and you're like the probability that you're going to change that, it's not really high. So infrastructure is more important at deployment stage because you need to know where you're going to host your model, how it's going to work with all of the system. And integration, which I also mentioned as well, is another focus point because when you're running experiments, you're doing this like in your own world, which is not connected anyhow in most of the cases to the, for example, to the back end or front end of your system. But during deployment, you have to think about integration issues as well. Quality of code, again, is seems like kind of obvious thing, but if you look at some Jupyter notebooks of data scientists, you will notice that not a lot of people are following that, because all of these rules of following quality of code, they are not encouraged and enhanced, for example, in Jupyter notebooks. That is why it's not really a focus point again during model training, but it's highly important during deployment. Also, testing is another probably obvious thing, but when you are training a model, you're running experiments. You're not like testing every line of code that you have. But when you are deploying a model, there is a lot of things, like additional things which you have to test. And I'm gonna talk a bit later about that more. And also login, which is convenient if something happens in production when you deploy the model, and it's like, again, an obvious step to do. So I made my share of mistakes during deploying machine learning models, but probably that's what you came for, to hear some of the failure stories I had and learn from them. So let's dive right into that. So the failure story number 1 is connected to scaling. And that's the story when I tried to deploy my first ever model. Back then I worked in a fintech startup, and I was working on a scoring model. And this first model, it was just a test, an experiment, I would say, because there was a lot of doubts whether this specific architecture would work out. And that is why at that moment there was a lot of pressure, like probably in any startup, to do that as fast as it's possible in the most simple way. And this model was deployed as a prediction service, as I showed it to you, but the architecture of the service, it wasn't great, I would say, and it wasn't super convenient to deploy a model, because it was working with every application separately, while when we trained the model, we worked with data in batches, so it required some code rewriting, there was some inconsistency, and it caused a lot of problems in reproducibility as well. So when I deployed this model, at that moment it seemed like it was just an experiment, but every temporary solution might be not temporary at all. I deployed, I think, more than 20 models using this specific prediction service, which wasn't made for that at all, and it wasn't scalable. It wasn't scalable because the architecture wasn't really extendable. You couldn't feed that many models. It wasn't scalable not just for different models configurations and architectures, but also for retraining this same model, which I tried to deploy, because you have to retrain your model. It never ends with just deploying one version. Probably you will have to change something in features that you use. Probably you will have to just update your data set if you have a data set shift or something like that. So what I learned from that is that we can plan deployment thoroughly. And that means that we need to think about all of the issues which could be important during scaling, even if it seems like it's not important right now. Like in my recent experience, when I tried to create different ETL pipelines which can be extendable in the future, it definitely paid off, because when I reuse them for for other features, I felt like how convenient it was thinking about scaling at the first step. Then there is always a reason to scale. As I mentioned, even if it seems like it's a temporary solution, probably it's not a temporary solution in most of the cases. And also it's much more expensive to fix something later, as it was in my experience. It was really it took about a week to create this prediction service, but then it took a couple of years of suffering with trying to deploy models which were not fitting into this service, as well as it also was hard to kind of stop at some point, to switch to another prediction service, try to build it from scratch by planning this time thoroughly, by hiring other people for that, because it was really time-consuming and expensive thing to do, and I wish that we tried to do that like at the very beginning. Another failure story is about delegation. So basically, that's about the moment when I started to lead in a team, and it was like my first experience of leading a team of data scientists. And because I was data scientist for about a year or so, like the only one in the company, I was used to how I'm doing my work and how fast I can perform tasks and what are the demands and so on and so on. And when you work with other people, you have to get used to their pace, to how they look at the tasks. Sometimes they have like other opinions and so on and so on. And for me, it was harder to push other people than to like push myself. So I ended up deploying all of the models which my team was working on. So basically we were like switching between training and deployment. Like my teammates were training the model and I was deploying them. And I was training the model, I was deploying my model. And it wasn't like the best way of work in a team and not the most organized, because basically I was the only point of responsibility in terms of deployment. And that prevented me from like having some breaks and working on some managerial tasks as well as researches and other models training tasks. And also there were situations when several of my teammates were training models in parallel and they needed to deploy them like almost simultaneously, and they had deadlines, and I was like the only person doing that. So at some point when I was already like on vacation, speaking at some conference, there was some bugs happening in production, and I was the only person who could fix them because I was the only person deploying these models. Also, all my team was available at the office and working on their tasks as well. So that was like the moment when I probably realized that it should be done in a different way. And so the first like lesson is delegation and delegation once more, because even if it's hard for you, it's usually pays off later. Also, synchronization in a team feels great. At least like for me, it was amazing that we could switch between different projects and tasks when we started to delegate a lot of stuff between us. And also, again, you're like human being, you can burn out from this, you can have some vacation or something like that, and you won't be available when you're like the only point of responsibility, and it's not the best way of working when you already have a team of people of whom you can rely on. As well as for them, it's important experience, because from what I saw, when you have like this deployment-oriented mindset and you already use it in training of models, you understand why you need to do some of the things ahead. And it's different from just hearing like, let's do these ETL pipelines a bit earlier, than actually seeing what happens when you're not doing that ahead and experiencing all the conclusions. So another failure story is that you're not the only person working on the part of your work, and it's not just about having a team of data scientists, but also about having other teams in the company. And this failure story is basically about the time when I was planning some work for a short sprint, and we needed to deploy several models. And at that moment, I totally missed that we need to work on integration with the backend team. And at that point, it seemed to be like a really small task that they needed to do, and it didn't require that much from them. But I didn't plan that, and it turned out that they had a lot of things to deploy to production as well. So in such a way, it was really hard to cooperate, and it turned out that they deployed something different from what they were supposed to in relation to our models. So that's when I realized that it's actually important to also pay attention to that too. So the lesson that I learned from this, that cooperation, it's not about just your team. but also about other people around you in the company. And sometimes it can be backend engineers, it can be some managers, it can be QA engineers. You might be working with, for example, marketing department, and when you are not planning your work accordingly, and you're not like setting your expectations and making them obvious to them, it can cause some troubles in the future and troubles in production too. And also, I think it helps to include other specialists when you're planning the resources, because when you're just relying on your team, it doesn't always mean that you're going to have a high quality deployment of your machine learning models. And also my personal like lesson, which I kind of promote in other companies as well, is that knowing more about how data science works, how do you build machine learning models helps, because when you miss something and you forget to discuss it with other teammates, when they already know how your work happens, they kind of know what to expect from you, and they may come even earlier asking you, maybe you need help with this or with that, and that's how it helping to cooperate and to deploy your models successfully. So the next story is about tests, and that's was again one of the first pipelines that I deployed with my team. And at that point, we didn't have tests because it's deployment of machine learning models, and in data science, it's not that common for culture of like engineering and data science to focus on that a lot, unfortunately. But right now, I kind of try to use this test-driven approach, which is more of an obvious thing for software engineering, but it's not that common for data science to use. And at that point, we had several features. I think it was one of the features was about employment of a customer. And we had like several categories, something like business, arts, and etc., etc. So all of these categories, they were encoded through the target variable, and so we needed like to know these categories ahead. And then backend engineers, they split one of the categories in two, and there was, instead of, for example, 5 categories, there were now 6 categories. And we didn't know that, and at some point we were just seeing that we had errors in responses of our prediction service. And then it turned out that they added like this new category, which we are not ready to pre-process, and which were not connected to our model anyhow. So we either needed to kind of substitute it with some default value, or like the better way is to retrain your model in this case. So basically, because we didn't have like a communication at that point, and like that's related to failure risk aversion, and also because we didn't have tests which could help us test out these cases, we had to like we lost some of the clients, because basically, as I show you earlier, when the model is just a part of some decision process, that happens that when you have errors, you're just not handling it properly, then you're probably gonna lose your customers on this like during this decision process. So the lessons that I learned in this story was to work with machine learning models requires even more tests than it seems, and it's not just about testing your code, whether it works properly, whether you're processing data properly. It's also a lot about data quality, and it's about as well testing the behavior of model. Does that model behaves as it was expected? Do you have like expected ranges of features? So you basically have data science or machine learning specific tests which would help you to see in the future if your model actually performs correctly. Another thing is that it's pretty hard sometimes to fix bugs like that in production, because you try to just debug and understand what went wrong, like for example how it was with that feature with employment, when you just like trying to look at the logs, trying to see like what specifically went wrong, and it would be much easier to prevent that with having some tests. So the next failure story is about not monitoring models, and this is like one of the probably most common stories which happen to a lot of data scientists, because when you have to work on a lot of different projects, you kind of forget and you switch to something else, and your model is running in production, something is happening, and you might see some errors, but you might not see what's the behavior of a model. And we have such a thing called data set shift, when the behavior of user changes and basically the patterns of their behaviors are different. So features which you've chosen for your final version of the model, they are not representative enough anymore. And in such a way, you have to create new features, you have to maybe use other data sources. And you cannot see that if you are not monitoring a model constantly, or if you're at least not having some kind of monitoring service which works per request, for example. And deploying and monitoring deployed model is more about checking at least the distribution of a prediction, which can be like, for example, a case which I had is when I trained the model for scoring some applications. There was a range of this score was quite close to normal distribution. It was from 0 to 1. But then when I deployed the model and later I just thought that maybe I should check that, because it seems like something weird is happening. I didn't have any monitoring service at the time, and I just saw that the distribution of this model was kind of skewed to the left, and in such a way, because I had some threshold for predictions, all of the users were like approved with their request for a loan, although not all of them should have been approved, just because there was issues with how the model behaved on the production data, and that there was differences in the distribution of data. And I could have seen that if I had some kind of a monitoring service. So the lessons which I learned from here is that monitoring also helps to see whether you're solving your problem or you're not doing that. And for example, I was building a scoring model which was supposed to reduce the number of clients who are not giving away the money back. And when I was like looking at this model later on, but again without monitoring service, but just because there was like some kind of intuition or something like that, I saw that it wasn't decreasing because we basically were predicting something slightly different. So the target definition was kind of wrong in relation to this specific business metric. So monitoring of not just distribution of your features, of prediction scores, but also of the metrics that you use helps to see just at once whether you're solving your problem or you just probably wasted your time on creating a solution which is not working. Another lesson is that we shouldn't forget that when we deploy a model, that's not the end of the story for this model. Probably we will have to retrain this model later on and get some new version, at least on the updated data set. Or maybe we need to change something in features, or as I mentioned, like for the previous lesson, to reformulate the problem and retrain our model on another target variable. So in such a way, we just basically we get to maintain our model, because maintenance is also a part of the model's life cycle. Also, you can do tasks like I suggested, like in the previous failure stories, but also there are other mistakes which might still be there. Like one of those I've mentioned, the mistake related to how the model itself behaved, and you wouldn't be able to predict that from the test, from looking at the results of the tests. You can see it only from monitoring your model. And also, I personally think that the essence of a work of a data scientist is to finding the answers to the question why something happens, or at least put in some kind of question and finding an answer to that question. And sometimes it means having 1,000 versions of your solutions and none of them are working, and you just know that nothing can solve like this problem at this point, for example, because of the data you have or something like that. So that's why when you monitor a model, you're like following the main, in my opinion, purpose of a data scientist to answer the question, why? So basically what I've learned out of all of these failure stories is that when you expect that something might happen and you plan that probably you will have to scale your solution, that in this case you kind of helping yourself and it's gonna pay off in the future when you're already preparing for scaling in the future. Also, if you have a team, you should work in that and delegate other tasks and try to synchronize your work. And this is not that common for data scientists because we often work separately on different projects. For example, if I'm working on a certain model, I will be probably the only person who's going to be deploying it, evaluating, and being responsible for that. And same works for all other people in the team. But when we share the knowledge, when we try to switch some of the tasks, and in the process it helps a lot to create much more effective solution as a result. Also, don't forget to work with other teams, with other departments, and it's not just about formulating the problem that you have, but also about like deployment specifically, that if there is an integration with a backend team, then you need to plan resources and work with the backend team on that. If there is issues with infrastructure, you should work with a DevOps team as well. You should work with QA engineers if you need to like test something related to the model. So all of this stuff also helps. And in my opinion, data scientists, they need tasks even more than software engineers. And it's not just about quality of code and the logics of the code that we write, but also about the quality of data that we use, also a lot about the models that we create, because we have a higher uncertainty in the stuff that we do, and that's why it kind of requires us to focus on that more. Also, in my opinion, model monitoring is the key to success because, again, it helps us to actually solve the problem, to see if we solved the problem that we worked on, to see if our solution is effective and accurate enough. So if you have any questions, you can also write to me in social media, and Restream is hiring for a lot of engineering positions, so check out that place. And thank you for your attention, and if you have any questions, don't hesitate to ask them. Thanks.
Thank you, Marianne. So thank you very much for your presentation. I'm looking at Pine. We don't have questions here. Maybe you have some questions in the audience. Yes, we have some. Can you say it out loud?
Thank you for the talk. I have a couple of questions. The first one, you mentioned tasks quite often a lot. Do you have any recommendations for finding tasks? I mean, where in the pipeline we should add them? Are there any standard tests? And the other one, I was curious about the automated deployment, because we have a couple of services, and I was wondering about that. Usually that is like push click of the button. Is that true?
Okay, so I will repeat the question.
Yeah.
The first one, as I understood it, was about ETL pipelines and what the standards around that and how to, yeah? Are tasks for the pipelines and if there are any standards. And the second was about, I forgot about.
So let's start with the first one. So it's
Yeah, okay, I will start with the first one. So unfortunately, I would say that there is no specific like data scientist-oriented tests guidelines, and that's probably because this sphere is not that old, and from what I saw like over these years of being a data scientist, that a lot of still developing, and since a lot of people who who come to data science, they come from a research background. They don't really use that much the culture of engineering, which is common for software engineers, but it's like getting better and improving over the years. So right now, there is no like certain standards for that. And I would say it's more about testing out stuff, what works for you, what doesn't. And about like also about tests, the only standards probably that you might use is about just testing your code, but how do you test the quality of data and how your model performs? It's basically more about experiments and trying things out and seeing what works out for you.
Yes, thank you. And let's repeat the second question so we can get it clearly.
Okay, yeah, sure. That was about automated deployment, if it actually works, and if there are solutions like that. It works from what I saw, that there are like different solutions like that, and I personally didn't use automated deployment tools that much, just because I had some specific cases which required like integration with different sources, and for me it wasn't really that much customizable. I would say that from what I often saw is that I needed some of the things to change, and it was hard when it's already like done for you. And that's why personally I deployed most of the models in a custom way. But yeah, it actually works, and you can try that out, especially if you have your model is not a part of the system, for example, and it's just called per request. That's definitely an option, and it's easier to do than just going through all of this process by yourself.
Thank you for your question. Do we have any more questions for Marianna? It's getting darker and darker, harder and harder to see it here. It's the lights are getting brighter. So if we don't have any more questions, then we'll thank Marianna for making the mistakes. So you don't have to. So a round of applause for Marianna. Thank you very much.